This is 7.4 part 3. We're going to do the examples where we have to find side lengths. So like I said in the previous video, when it asked you to solve for a triangle, you would basically find everything about the triangle that there is to find. But in some cases, I'll just ask you to find a particular length. So we're going to use our trig ratios to do that. Just as a reminder, we're going to write down SO katoa to remember what the trig ratios are. So katoa, always write that down at the start of every quiz, test, or assessment you have. And so find the length of the indicated side using the appropriate trig ratio. So let's start with triangle A over here. Usually when you name triangles, what you do is you would write triangle, and then you'd name the vertices, so A, B, C. So this is triangle ABC. And we want to find side A. That's the indicated side. So our goal is to find the length of side A. And the reason I know it's a side is because it's a lowercase letter as well. And notice that it's opposite of angle A. And so we want to use the appropriate trig ratio to do that. The first thing I want you to notice as well is that this is a right angle triangle, so we can use those trig ratios. One thing I usually do when I solve these type of problems, even though you don't have to do it here, is I like to find the remaining angle just in case I want the option to use it. So remember, in a triangle, just to remind you that all the angles are equal to 180. So if I want to find angle A, so this is just an aside, angle A, because sometimes you might need to do that, you would simply do 180 minus your other angles, so minus 90 plus 63. So you'd add the two angles up that you have and just take them away from 180, and that would give you your angle A. So you'd be doing basically 90 minus 63, and that would give you 27. So we know angle A is 27. So we have 27 degrees here. We didn't need to find it, but like I said, sometimes I just like to find all the angles in case I want the option to use it, because there's a few different ways you can solve the problem. We want to find side A, and so we can look at what ratio would apply to side A. So we could use cos, we could use sine. I'm going to go with the this angle here. I'm going to start using this angle. What I want you to get is that this angle is related to side A and side 9.6. 9.6 is the hypotenuse. And side A, if you were looking at angle 63, is the adjacent. Side A is the adjacent, and then 9.6 is the hypotenuse. So we have adjacent and a hypotenuse. And so what we can do is we can go look at which trig function has adjacent and hypotenuse. Well, it happens to be cos. So what we know is that we should use cos. We know that cos of angle B is going to be the adjacent over the hypotenuse. And so we know that cos of angle B is cos 63 is equal to our adjacent, which is A, over the hypotenuse, which is 9.6. So we're just replacing the values that we have there. And now what we can do is we can solve for A by multiplying everything by 9.6. So we get 9.6 cos 63 is equal to A. And so make sure your calculator's in degrees. We'll do 9.6 times, push your button cos, then hit 63. And we get, and I'll round the two decimal places, 4.36 centimeters. So we get A is equal to 4.36 centimeters. Make sure you put your units and make sure you write this as a therefore statement, but that's the point. We got A is equal to 4.36 centimeters. Another way to have solved this, so this is solved, but just to show you a different way, you could have, because you found angle 27 over here, you could have used a different relationship. You could have found your angle. How is this angle related to side A? Well, if you were looking at angle 27, side A would be the opposite, and 9.6 would still be the hypotenuse. So you'd have opposite and hypotenuse this time. So you would have sine A is equal to opposite over hypotenuse. I knew it was sine because so, opposite over hypotenuse. So sine of 27 is equal to the opposite side over the hypotenuse. Let me just write the hypotenuse down. Oops. So sine of 27 degrees is equal to the opposite side, which is A, over the hypotenuse, which is 9.6. And so when you solve for A, you would get 9.6 sine 27 is equal to A. And if you put that in your calculator, so you would get 9.6 times sine, make sure it's in dag, 27, and we get 4.36. So you could have done it that way as well. It gives you the option. It's a way to verify your answer. What I would usually do is I would use the numbers given to me in the question, just in case I made a mistake over here. So use the number given to you in the question first, and then verify with another angle if you have that available to you. So there we found the missing side A. And if you want to find the other side after, so let's say you want to find side B, you could use a trig ratio, or you could use your famous a squared plus b squared is equal to c squared. So notice there's a variety of ways that you can use to solve for the triangles altogether. So let's do question B over here. I know we're only supposed to find side B, but I'm going to say let's solve for the entire triangle. Let's just do that. So first, when I'm solving for the entire triangle, I'm going to look for any missing angles that I don't have, because they're pretty easy to find. So again, in a quiz question or test question, just find whatever I'm asking you for, but if I say to solve, you got to find everything. So one, I'm going to find angle B by doing 180 minus the sum of my two other angles. I know that this is 90 degrees here. And so I'm going to get 180, which is basically 90 minus 75. So that should be 15 degrees. So I have 15 degrees here. I'm first going to solve for side B. So we want to find side B. I'm going to use the angle that they gave us in the question. The angle they gave us in the question is 75. So how does side B relate to 75? Well, side B would be the opposite. Or would be, sorry, not the opposite. Like that. Side B is touching 75. So side B would be the adjacent side to angle 75. And this over here is side C. It's opposite to angle 75. And then we have our hypotenuse over here, opposite of the 90 degrees. But we have adjacent and hypotenuse, adjacent and opposite to deal with. So which ones have adjacent and opposite? It's not so, it's not ka, but it's toa. Opposite and adjacent. So we know that tan of angle C, which is 75, is equal to the opposite over the adjacent. And so we know that tan of 75 is equal to 4.2 over the adjacent side, over B. And so we can solve for B by multiplying both sides by B. This crosses out here. And so we get B tan 75 is equal to 4.2. And then we can divide both sides by tan 75. This crosses out, this crosses out. And we get b is equal to let's do that in our calculator. So 4.2 divided by open brackets tan 75. Again, make sure everything's in degrees. And we get, rounding to 2 decimal places, 1.13. 1.13. Let's make sure when we're approximating, we're doing an approximation, we put a dot on top there. Centimeters. So b is 1.13 centimeters. So what we've done is we found side B, we found angle B, and then if you were to solve the triangle, you could simply now do, and I would carry this in a more logical order, logical steps, but if you want to find the hypotenuse, which is side, which is the hypotenuse over here, we would have the a squared plus b squared is equal to c squared. And so you could do your 1.13 squared plus 4.2 squared. Again, I know the b and the c, they're a bit confusing here in our formula for our hypotenuse. C squared represents the hypotenuse. Just remember that we're using our opposite sides, adjacent sides, use from the triangle to find the hypotenuse is equal to c squared. And so let's go square those. So we get that squared plus 4.2 squared. We get 18.9. 18.991 is equal to c squared. And so c would be the square root of that. Square root of 18.91, which is 4.35 centimeters. And so we found 4.35 centimeters. Again, the question was only asking for side B, but I decided just to show you how we'd solve the entire triangle if needed. But if you're just asked for one, don't worry about looking for everything unless you need to. Sometimes you might need to find another angle in order to find the side. So now we're going to start question 6, where we have to find the measure of an angle rather than the measure of a side. So these questions here, we were looking for sides. Now we're going to find the measure of an angle when we're only given our sides here. So we're going to try to use our inverse functions that we learned about earlier. We won't have time to finish this example, but we'll finish it in the next video. So let's say we want to find angle A. Let's see how these sides relate to angle A. Well, 5 would be the opposite side for angle A, and this is just our hypotenuse because it's opposite of 90 degrees. But 5 relates to the opposite side. So we know that sine of angle A is equal to opposite over hypotenuse, so SOHCAHTOA. Remember that, so SOHCAHTOA. So sine of angle A is going to be 5 over 12. And in order to find what the angle is, what angle A is, we would do our inverse function of that. So we would do inverse sine of 5 over 12. And we would get that angle A is equal to, so let's do that. So inverse sine of 5 divided by 12, put that in brackets, that's 5 over 12, would be 24.62.